Here we're asked to find y in terms of x, given that the derivative is 4y squared plus 1. So this means we're going to have to use the chain rule to be able to anti-differentiate this expression. We also have a point here, which means we'll be able to get a unique solution. So the first thing we're going to do here is if dy dx equals 4y squared plus 1, then dx dy will equal 1 over 4y squared plus 1. Now this starts to look like an expression that is going to give us an inverse tan relationship when we anti-differentiate it. So therefore x equals the integral 4y squared plus 1 dy. And now we've got all our y's over this side and our x over here, so we're in pretty good shape. Now remember, when I'm anti-differentiating and I'm getting a tan, I need to have my y squared and my a squared, or my x squared and my a squared, remembering that the form that I'm looking for is a over x squared plus a squared. And that's going to get me, if I integrate that or anti-differentiate that, that's going to get me to tan negative 1 of x over a plus my constant. So I have to mess around a little bit with this and do some fancy footwork. The first thing I'm going to do is I'm going to take out this 4 because I need that to be a single x squared, a single positive x squared. So I'm going to write x equals 1/4 outside of 1 over y squared plus, now this 1 here becomes 1/4 dy. And now this needs to be expressed in terms of an a squared, which means that a must be 1/2, and therefore I need to put a half on top. If I'm putting a half on top, then I need to take a 2 out the front. So I'll end up with 2 over 4 outside of 1/2, that's my a, y squared plus a half all squared dy. And this, of course, is going to simplify down to 1/2. And that means that when I anti-differentiate that, I'm going to get that x equals 1/2 tan negative 1 of x over a half, or should I say y over a half, and this is going to become 2y, and then I'm going to have plus c. So therefore x equals a half tan negative 1 2y plus c. Now what I'll need to do is I need to express y in terms of x. So that means I need to now have x as my subject and not y. So I need to take this apart. If I want to, I can actually forget about my x right now and add it once I've expressed y in terms of x. What I'll do first of all, though, is I'll start moving things around. So let's keep the x there. X minus c equals a half tan negative 1 of 2y. And then I'm going to multiply both sides by 2. Now it's time to take the tan of both sides, and I'll end up, I'm just swapping them around here, 2y equals tan of 2x minus c, and therefore y equals a half tan of 2x minus c. And now what I can do is substitute in my point so that I can find my unique solution. And now what we're going to do is substitute these points in to calculate our c. So therefore 1/2 equals 1/2 tan of 2, and x is 3 pi on 8 minus c. Now I'm going to multiply both sides by 2, so I'll have that 1 equals tan of this business, and therefore that this will equal pi on 4. So 2 outside of 3 pi over 8 minus c equals pi on 4. And then I'm going to keep my algebra going. that'll be pi over 8. Then if c goes to the other side and the pi on 8 comes here, then I'm going to get 2 pi on 8, or pi over 4 is c. Which means finally, if I'm going to represent y in terms of x, then I'll substitute this c equals pi on 4 into this equation here. And my final answer will be that y equals a half tan outside of 2 x minus pi over 4. And that's completing this derivative and turning it into an equation. If you found this video helpful, please subscribe or like. Thanks.